Good afternoon, good evening, good morning. How's everyone doing? Welcome, Zrencho. How are you?
Good. How are you, Steve?
I'm doing great. A bunch of people here. We got Bill and Neil and Huge Dino and Tuxedo. How's everyone? I wanted to do this extra stream here because we weren't able to make a Sunday work, just schedules and stuff. So I thought it was a good opportunity to use a Wednesday here to bring Zrencho, the creator of this project, creator of Nudge, which we use in this project, and just have a chat about it and why this exists, what its history is. You've got some little bits and pieces you can show off, kind of showing the development process, and we're gonna get a print started on this. The build is complete. I did this Voron Frostbite Christmas ornament. I missed, I didn't put one of the pieces on the plate, otherwise I'd be able to assemble it, but I missed the whole side. For some reason I didn't notice I only had 5 sides on the build plate. But this printed right after stream last Sunday with no other changes to the printer. The entire problems we had was I was docking too fast. So yeah.
A little dawn makes the difference.
Now,
did you add any adhesionate after?
Well, yes. I cleaned the build plate. Definitely. That was the biggest difference in the print, basic print success. But yes, I cleaned the build plate and then set that print to go. So now in between the streams, I have adjusted. I reprinted this dock because we tweaked it. I tweaked it during the miss docks last week, and I modified the ooze blockers. I got rid of the brushes altogether. I didn't want to add anything to the equation that could cause a tool to drop off, and that wasn't absolutely necessary. And I feel that the ooze blockers are necessary, but the brushes, I'm going to move one brush down here next to the nudge, because the only time I feel like I really need to brush is before I go to nudge. So
I think that makes sense. Let's give it a try, see how it does.
keep
Maybe
it
we don't really
simple.
need brushes. Why not?
Yeah.
I saw a note about audio mismatch, so I just dropped my volume a little bit to
Did they
be
say
closer
you were
to you.
high?
If someone else can confirm,
A lot
thumbs up,
louder.
thumbs down,
Okay.
we can get closer.
Yeah.
We got plenty
awesome.
of dynamic range here.
Yeah. Hey, Build a Basement. Jay Waller, Mark. I'm not going to catch everybody. It's a little more difficult. Still a little loud is what I'm hearing. I can adjust on my side too, but I don't want to double adjust. So if you've got the ability, then...
I just went down a step.
Okay. Awesome. So,
Steve is low.
So I'm always low, and I've noticed this also. I've noticed the question of volume here. It seems to be that YouTube is relaying a lower volume during live streams. On the playback, it gets louder. So if you're comparing me to other pre-recorded content, then it's not a good comparison. Not going to spend all stream playing with volume levels. At a certain point, it's just going to have to be good enough. It gets too frustrating other ways. Too low to be acceptable to watch? I don't know what to do. I can't turn mine up anymore. Too low to be acceptable to watch. Yeah. And when we get the two sides, that I'll get equal number of people that say they can hear us fine. So anyway, let's just keep going.
Steve, you sound great to me.
You sound great to me. It's perfect. That's all that really matters. You and I can talk, right? Question and side question. This always comes up. Why do I use the Prusa build sheet? Because I like it. Because it fits in a 250 pretty well. I lose a little bit of Y volume, but I use them because I like the Prusa textured sheets. So, people on laptops and mobile, they're kept out on volume. Anyway, Mad Max, how'd it start?
I always wanted to do a tool changer, and I was always scared.
Tool changes are awesome.
I think they're super awesome. I had seen E3D did one a while ago. There were some videos on YouTube of deltas. There were so many tool changers before this one. This is in no way the first or anything like that. But I always wanted to do one that was compatible with 4-ons. And of course, I tend to do the Ant thing with V0 mods over and over. The same frame kits, just repurposed, kind of like a Lego set that you build a different model out of each time. And I did everything but a tool changer until there was nothing left, and then I did a tool changer. So I haven't answered your question, right? Why did I actually do this one? But it was more that it was kind of the last thing on the list. It was the one on the bucket list that I thought would be interesting, that I thought the coupling would be the biggest challenge, because you have to make it kinematic. It has to be repeatable. So it has to ensure that that head every single time goes back to the exact same spot. It generally has to fit in a compact space because we don't have extra space in our tool heads. Exactly. And I started about a little over 2 years ago on it. And actually I've got the first object. I was talking with John Shona from Proper Printing. He had mentioned that he also wanted to do a single axis tool changer on a bed slinger, and he wondered if he could use a push-push latch for that. And I wonder if the audience here knows what a push-push latch is. It's like if you've ever had a trash can lid that you can push down, it stays closed, then you pop it again, or a cabinet latch like that. Got one here, actually.
Oh, there you go. Here. There we go. Interesting. Hold on. Sorry. I think my bad. Let me see here. Here we go. Okay, I had a mistake there. So let's see if you would talk real quick. Make sure that we get audio from you.
Sure, I'm talking now.
Yeah, so they should hear you now, and that's my bad. So they didn't hear any of that explanation. I sincerely apologize. You want to start over?
No problem at all. Okay. Where did it come out? That was the question. I was showing a fun little toy on screen.
Yes.
And this was like the little desk prototype after I talked to John at it was Open Sauce 2023, and I thought, okay,
from Proper
John Shona.
Yep.
Cool ideas. We talked about belt extruders too. Love the guy. Wish I could hang out more. So this is the mechanism, the kind of fun desk toy that I thought, let me play around with a push-push latch, see if that could be a good docking mechanism, and let me see if I can make a Maxwell coupling. So a Maxwell coupling, if you see there, we've got pins on one side and we got balls on the other. And that's all it is. It's a mechanism that enables this to go back to the same place every time. Balls and pins. And that was kind of where it started. I thought, okay, that's kind of cool. That was in October or November. And then I realized if I was going to do a tool changer, I needed to align the nozzles. And I had always, part of why I didn't use the IDEX I had made and the dual gantry setup called Dueling Zero is that I didn't have a good way to align the nozzles. And so thus began kind of the first spinoff, one of the first spinoffs, which is Nudge. It's a spinoff of Mad Max. And you see one on Steve's. Looks kind of like this. This is the 5mm pin version. And it's just two pieces that we got it down to in the end. Also a Maxwell coupling. It's on the inside, and it's a switch. So when you move this around, when you move it around, it breaks the contact. And then as your nozzle taps it from all directions, you can get a relative offset. Now, this is not the first nudge. I don't think most people have seen this unless they've looked at the nudge page closely at the bottom. There's a big picture of all the prototypes, and there were actually about 60 separate designs that were either proposed, printed, or tested. It's a lot more than people realize. One of the first designs was completely different. So it's right here. And it was a lot of stainless steel, but it was the same concept of you have a switch that breaks, but I was trying to do this without any soldering. But it has a bunch of issues, like you've got metal going into plastic, and you want to make sure those areas are really strong and that you've got a good way to attach it. And a lot of those prototypes kind of found their way over to, this was a version show one more. Has a lot of the elements, and there was this concept here of a detachable base, and you would just change out the base to the one that you want. And same kind of, it wobbles around going on. Started to add a JST to the end, and this had a lot of mounting flexibility. You can see that an extrusion fits right in there, and you could ditch this and then do an index mount where it would fit right on top of the bed if you didn't have over travel. But then for months and months, I was building test jigs. I was trying everything out. Here's an example of one of those test jigs, little scene part. And the purpose of this thing was to have the most solid possible mount for a nozzle to a carriage with the printer. So I could bring it around and I could get really high accuracy positioning. I didn't have to worry about the head. And I was testing stuff that looked like this. So originally we had a spring that was providing the pressure. There's a little spring on the inside here that's pushing the wobbler up. But it has a lot of the elements that are pretty familiar now. Now it has one thing too, which is I was going crazy because I kept getting this drift over time, where it felt like if you kept hitting the tip, then the reported number kept slightly varying. And so this has washers on top and bottom. It has screws. This is actually pretty good design, and this is not the one that I'm trying to see if it's here. There's a design where I had metal everywhere. It actually had the washers and a vertical screw compressing the side screws that right now kind of touch on the tips, and that's what closes the switch contact. So yeah, the thing really evolved, and for 2 months I was going crazy until I learned a very interesting thing about belts, which is that they stretch. They have what's called viscoelastic relaxation, if you want to sound nerdy to your friends, and it's a property where they'll stretch and then they'll slowly come back. And so if you hit them with enough force, they'll just pop out a little bit, they'll go back slowly. So if you hit them enough times, they kind of stretch a little more.
Oh, okay.
So I was measuring the belt stretch. The sensor was fine.
Interesting.
And so nudge was one of those first pieces. There's also vampire bat, which is a way to have a front-facing gantry on a V0 size printer, which you need if you're going to make a V0 tool changer, and that was what I had available. So there are all these little pieces that had to happen, and then I worked with the beta team. We did like a really initial version. Those initial versions, I actually have one to share if people are curious. I don't know, is anyone curious? What do you think?
I am.
You're curious? One vote's good enough for me. So everything about this is different relative to what we released and what you used.
Do we want to go to the angle down view so we can
yeah,
turn
let's
off
do that.
views so it doesn't?
Let's do that. Yeah, I think the blur is kind of
obscuring some of the pieces. Yeah.
Let's do that. I got a good setup for it. No blur in the way.
There we go.
Awesome. So this is a front dock, front of the printer right there, that has 3 screws, and the idea was you'd put those screws into the front of a flat front of any tool head cowling. You notice it's the same flathead screw idea with really simple keyholes, but this actually had a magnetic pusher plate.
Oh, interesting. That pushed
it.
Screws back into the keyhole.
Yeah, because I didn't want to have any slop in the mount. I didn't want to depend on the magnets for that. I wanted it to push in. So this thing pushes in and slides over, and then it locks in place. And the pusher plate there ensures that there's pressure on it, and it makes things really smooth in the detach and the attach. It kind of adds a nice spring motion. I liked that, but I think it's too complicated. I realized we really didn't need that, so I moved to a much simpler design. And I moved to a side mount because I thought it removed this ugly thing in the way. And it was just completely blocking the view, right? Where's my tool head? Where did it go? And if you have 2 of these in a V0 space, there's just enough space to see through the center. So you also lose the side motion
right
on your X. And so there was literally no way that I could use this design on a V0 and still have nudge have enough travel above and below to, hit the nozzle properly. One other change is, and I think there's a lesson here for anyone who's a budding designer. If you can design to maximize the speed of iteration, it always wins in the end. So I had taken things that worked for me. This was never released, but this is a variant of Boop on which I replaced the MGN9 rail in front. And I added the lightest design I possibly could that got me some magnets and some pins. And voila, I had a tool changer coupling that I could then do tests on. I could learn all kinds of stuff with it. I could do reliability tests. And after I did a few thousand cycles, I was like, okay, maybe there's something to this design. It seems to be, I'll move it a little farther back, see if we can get focused there.
There we go.
Looks in focus on mine. I don't have a good sense about the resolution I'm uploading at. So this was kind of the core idea, but you'll notice this is backwards from what you've got.
Right.
The pins are on the carriage here. Let me phrase, the screws are on the carriage here. The pins are on the tool head here. So the design we went with is the opposite. Let's see if I can find my carriage.
Cost and complexity, switching it.
Yeah, I thought it was better packaging because I could do it all in less space. And so the other thing that's really nice is eventually we switched. I mean, there are a few other designs here. You can see some of the progression, right? We had the screws on the outside coming in here. And then I started adding thicker, beefier legs and trying out maybe a bigger version. And this version even has a feature that never made it, which was the idea that you could also use this as an easy attach detach tool head. So you could put a thumb screw in here. And then there was a plate that had a heat set embedded at an angle. And the idea was you'd lock it down and then you could see if the tool changer coupling was contributing to input shaper issues. And you could just lock it in so you'd have an easy attach detach tool head where the screws from the back so it doesn't get in the way. Ended up abandoning that because if you tighten that screw, it wants to pull the thing out of the tool changer coupling. So it doesn't work at all.
Yeah.
It's terrible design. But I didn't see that coming. I still think it would be a cool feature, but you'd have to have the screw coming in straight from the back instead of at an angle. Anyway, it evolved. We had lots of prototypes, started expanding the group. There were about 10 people, part of the beta, that were able to get theirs to do 2 different extruders. That was kind of the standard. Every time 1 or 2 people got it working, I'd add a few more people to that beta. And that's how we ended up at kind of the final design that you're using that has a very strong plate despite it being extremely thin. And out of the box, I wanted to add support for a lot of the common tool heads, and where the support really came was from the community and the beta testers. And so we've got, Mad Max plates will fit V0 compatible heads. So this is mounted on an ant head. This is in a filament color that I really love. This is called Sunfire Helix from Fusion, if you like this orange. This is Dragon Brick. Let's get that in focus. Come on, Logitech 930. Here, I'll try to blur and unblur and see if that forces it. There we go. Found a workaround. I think this is really good looking. This is extremely compact in the Y dimension, and on a V0, you don't have a lot of space, so you really want it very narrow in that Y dimension. And this is a modified front for a K1 extruder. I think Rob did this design, and it's got the latch to unlock. It's got an accessible feed. It's very compact. It's got metal bits in there. And this is also a design I really, really like. This is, let's see, is this locked in with a screw? It is not, but it has that enormous Molex on there.
What is that? Is that on a Hoovid?
There we go. Oh, I think this one has a screw in the back. I forgot about that. That's why it's not coming off. So I will not force that one. But this has one of those square tool head boards in it, which I really like. And just with Mad Max having the tool head on the front, it's not a common thing. I haven't seen it much at all. But if you have a tool head that's narrow enough and wide, it's not putting too much weight in front and messing up with shaper. Yeah, I think it's an EBB 42 on this one. So that one, it's pretty cool. This is a stealth burner turned into a stealth brick, and the brickifying is just 2 things that you're putting on a flat front with the tool head board, so it all fits in very little space. And then it's making the sides a bit more of a slab in the sense that if you have a flat face, then it tends to work pretty well with the screws sticking out that do the docking motion. And the community's come up with all kinds of docks, all kinds of tool heads. I mean, we've got a lot of stuff in my box of fun here. I mean, we've got, this is one that Andrew did. This is pretty much this is not the one Andrew did. This is the one that Andrew did. So it took a stock A4T, added our flathead cap screws for an unmodified A4T.
Yeah, there's heat sets on the side of my stuff here that would allow me to mount that. But, yep.
And then the other one, so you see that it doesn't modify the tool head, which is pretty interesting. I never thought of that. Andrew did. And that same carriage looks very different than the others, but it performs the same function. It's got 3 screws in the right positions, all the same ones. And something to point out here is the big head is using the small spacing for the small ones. So if we were to start from scratch, right, if we were to optimize for your use case, the kind of XL tool head case, you'd make some changes, right? You'd increase the size, you might put them in different spots or flip the orientation.
Right.
You would most certainly go with a much wider spacing for these guys. And I know that your tool head has slightly wider. And in fact, the reason for it here that these are the same spacing is simply that then you could reuse the docks.
Right.
So yeah, we got a lot of tool heads supported. One of the challenges at the moment is that some of the beta testers didn't share things in the form that would make them very easy to find. I'm going to be working with them over the next few weeks to make sure that all the ones that I had the luxury of printing from a private share are made available at their GitHubs or on mine if they want to send me a pull request. I got to wrangle them, and this isn't their priority at the moment for many of them. But we've got a bunch of docs, and you've made your own. We've got a bunch of toolhead mods. Didn't release support for, but I mean, well, the support is there, but I don't think anyone's going to use it. A mini SB, actually unmodified or minimally modified, where you just add the holes at the bottom that really lock the plate in. That's another supported option. So yeah, we got all kinds of docks. We've got all kinds of heads, but I like when people make it their own. And I love seeing the completely different design that you had done. I like seeing the completely different blockers and brushes. Here, I'll get one more head that I think is kind of interesting and showing just how narrow things can be. So this is the one that I'm using on my converted Double Dragon. So it's a wide V0 that used to be an IDEX, and now it's a Mad Max because I get a bunch of benefits from it. And it gives me also a way to test stuff again. For a while, I didn't have something that could run it. But this, to my knowledge, is one of the narrowest and Y tool heads you can find. This is also kind of interesting because it uses a belt extruder. I don't know if anyone's seen the Papilio Light by Kevin, aka Sam, but it is a fantastic extruder, and it has an accessible feed. I added a little clip to mine so the CAN cable comes out and then up, so it's nice, properly strain relieved, very narrow in all dimensions, very compact. But I think the market has moved on, the open source market, and I think 40 millimeter seems like where most people are going because you get that extra cooling versus the 4010 versus 3010. So I personally want to do something like ant head. This is an ant head with a flat side that has the integrated screws. And that's it. That's kind of the point, that it was always meant to be a minimal change.
Right.
Yeah. I haven't released this one because I kind of don't want to. I want to shift the support to things that are just more broadly used and supported. I think that will be better for the community in general. Also, I think it looks pretty good, this tool head, and support for all kinds of stuff. And I think if I could combine the two and get Papilio Light, which is my extruder flavor of choice, along with a more commonly used tool head body, I think that would be really good.
I need to build one of those extruders. I just need to get around to it.
They're not without quirks, but I really have enjoyed using them for a few years. You never have to worry about issue 6 of extruder variation being visible on a print. They're very compact and have this really nice property of so much space is available in front, right? You can see where the filament is sticking out, and it's only a few millimeters to the front plate here. The wide BMG gears aren't the best there. Now it does add some weight because you're still adding 2 layers of reduction here to get this thing to overcome the resistance from having a belt that's squeezed. I don't know if everyone knows, but the Papilio Light does something very clever. It uses 3D printed, slightly curved, GT2 compatible drive pulleys. They're hidden here, but they're on the inside. You can just kind of see the belt sticking out right there. A little bit of motion there you might be able to see. And the filament is squeezed between 2 belts, so it starts to take kind of a little bit of a U shape around as it molds to the shape, and the pulleys grabbing it have GT2 belt little closed loops. And so the notion that you can even 3D print a curved GT2 pulley blows my mind. And the rest of it is just really, really cleverly designed packaging. I really like stuff like this, or stuff like HGX gears or LGX gears aren't as deep like the BMG gears, so you can package them much more nicely. And I think they also give the much larger surface to push the filament, which helps reduce issue 6 and give you good extrusion.
That's awesome.
Yeah, all the parts you've seen are printed on Papilio, and they're all like, they're pretty darn good, I think. You can't see any of the layer lines at this res, of course.
Yeah.
So I was talking and looking into the camera or showing things. I'm sure we've got some questions. Maybe we can take a few.
Does the cooling for the extruder flow over the tool head board? Since it's directly above the heater, it seems that it would need cooling. I think that was in reference to the one of the designs you were showing. The brick, the one with the tool head board in the front of the extruder.
Was the question about cooling of the tool head board?
Yeah.
Yeah, I've personally never had issues with tool heads and chambers. Maybe I'm not pushing the chambers massively hard. Maybe, yeah, here, I'll put it back in view. I think we're talking about the tool head board right here. I added some holes, and its own motion should give a little bit of cooling. I'm not pushing a high extruder current generally. The pillar light doesn't really need it. And from what I've seen, it isn't an issue. Steve, one other thing you might appreciate is the wiring is very clean and tight. Because
yes.
One of the changes we made was to use the plate as a means of restricting the wire motion, so that the chance that your wires get squished is very low. It's squished during assembly rather than squished during motion.
Yes.
I don't have an extra zip tie on the other side here, but if you do that,
fewer zip ties than I used.
Yeah, I have actually have just the one zip tie here, but the tool headboard cover actually just slips right on, and then for extra security, right here there's a flathead cap screw. So it's a very thin design. I really like it. It's about 1.5 millimeters. I hope that answers the question. If you're in a super hot chamber, tool headboard may not be the right choice anyway, regardless of whether there's a little cover in front.
Yep. So that is the evolution and why, kind of where we got to Mad Max here. And now we've started to see builds out there. And the documentation has evolved and all that kind of stuff. What's next?
Yeah, it's a good question. So where do you go from here if you've built the tool changer? What do you think I should do, Steve?
What is the next problem to solve?
Or what is the problem?
So something I've not, the thing that I've found from your designs, starting with Nudge and moving on towards Mad Max and stuff, is I'm very impressed and very, everything is very clever in that you're using just parts off the shelf. I mean, Nudge is some screws and printed parts and magnets, which, by the way, I put copper screws on this. And because I was going to completely rebuild and it was taking too much time, so I just tuned this one up a little bit. But and then Mad Max, there's nothing really special. There's nothing hard to get in the Mad Max mechanism.
Yeah, the initial versions were all steel pins, and it worked just fine. I was able to use I don't know, I didn't even mention this, but so Maxwell probing is kind of interesting. It's where the probe itself and the Maxwell coupling acts, like the Maxwell coupling acts as a probe. If you use it, you kind of push it, and then the switch breaks, and you can use that switch to be an end stop. You can use that switch to be which head is detected, which Clipper tool changer needs to know. And then it also can do the probing thing. And so it used to actually, we had all that working almost 2 years ago. And the problem was that at higher chamber temperatures, it seemed like the quality dipped over time. And this is one of the challenges, that sometimes we're kind of on the margin with components, and we don't know till we bring up the temperatures, or we increase the duration, or we increase the pressures, right? Until you change the environment and really push it to the limits. And my tool heads aren't particularly heavy. They're around 300 grams. But when you have bigger ones that have heavier extruders, especially things like G2E, I think is a bit on the heavier side compared to something lighter like a BMG, that extra 100 grams-ish. And also if you have a bigger, taller hot end, it can weigh more. Those grams start to add up. And the coupling was never designed to handle big torques trying to drop it off. So part of me wonders if we should take all the lessons you've learned, others have learned, and do kind of an XL version. Part of me wonders if we should do something other than plastic. You got a lot of choices these days, and a lot of places that fab stuff for you. You can get CNC that's custom done for low prices. You can get circuit boards done very cheap. So I have to wonder if we're trying to make strong structures with electrical contacts ideally embedded and precise positioning of components cheap. I mean, that screams out PCB design to me, or PCB plus plastic hybrids.
Yeah.
So I think that would be an interesting direction to take both Mad Max as well as Nudge. Can you eliminate failures?
Yeah.
And a lot of the issues you saw recently, like with Nudge being a little on the unreliable side, I recommend now that people use a filled filament for that, because it's just more stable over time. But still, whatever the filament is, if you crank a screw, which you want because you want to get a good electrical connection there on the screw tips there, that screw is going to cause creep, right? Creep is deformation over time, typically under pressure, but also under pressure at elevated temperatures, especially where material changes, just slightly squeezes. So it almost like it flows over time, but it flows very slowly, and slow flow we call creep. It's a material property, especially plastic. So by tightening that screw to get the metal connection you want, we're actually causing that metal connection to be bad in the future because the plastic around it is going to be pushed hard. And typically you tighten it a few times and it then settles. You're effectively relieving the pressure of the plastic around it, especially with temperature cycles. And I found that a lot of my parts would stabilize after a few temperature cycles and tightening cycles. But I don't like the potential for failure here. Ideally, things just work. And ideally they have, kits of components with fully off-the-shelf parts. We almost got there with Mad Max. It's the only part that's special, I would say, is the stuff that you can see in white here. Those are the acetyl pins. Acetyl. And acetyl, Delrin palm, same material. And it's a very hard-wearing plastic. Originally, we'd done steel, but it was too much force. It was almost a kilogram. And then we moved things to PTFE, right? Teflon. Super slippery. Even built a tester to measure the friction coefficient on a little tiny sled weighted with a stepper. Got all those numbers. That's all on the Mad Max page. You can see a graph of all the different materials we tested. And it was, as you would guess, PTFE, wiped the floor with everything. It's 0.1 coefficient of friction. Super slippery. Problem was getting bashed with magnet forces. Didn't take very well. You could see the deformation almost immediately. This was one of those changes of find the happy medium between the hardness and hard wearing of steel, the softness but the slipperiness of PTFE, and the in between hard wearing but still slippery was acetyl / palm / Delrin. Yeah, it's fun to try to design within the bag of parts, right? To just start with the one Lego set you've got, but often if you want to get really good long-wearing design, you have to find a part or two that's special, and then you got to figure out if it's worth that added sourcing complexity. And something I really appreciate that the Voron design team has done is show a way where things are world sourceable. And I try to follow their lead and make everything as sourceable as possible until it becomes a limiter to performance or longevity, in which case you don't have a choice. You bite the bullet, you go.
So things go ahead.
I just saw a note. Someone said coated steel pins next time. Yeah, so if you grease the pins, that'll actually help, and that's kind of a stopgap. But ideally, the community will find some other ways. Like maybe brass is the best choice. There's a chance that maybe I just haven't tested it. But to really get an answer, you need to build something that probes repeatedly 10,000 times and make sure that that connection is still reliable after those 10,000 taps, ideally, and that the probe force is not too high, and that the deviation on those probes, it isn't just that they're successful, it's that they're consistent. There's a lot of testing behind the scenes that goes into this stuff that some people may never even be aware of, but it's what makes this stuff pretty reliable out of the box, or at least we'll know what the limitations are. And I try to reveal those on the GitHub the moment it's released as much as possible. If people want to know more about Mad Max, there's a stream for its release that's on YouTube on my channel. There's also West 3D Meet the Makers that I did recently. That's more kind of like this interview with the creator, walking through the different parts, plus broader history.
Let's get a print going. And then while it's going, we can continue to answer any questions. So any questions that come up in chat, if you don't get your question answered in a reasonable time, feel free to repost it, because it is a little more difficult to follow chat with a guest here. Real quick, the things that I changed in between is I changed the docks, but I also, after chatting with you, talking about doubling up the magnets to give more holding force on the tool in the dock, and it made a pretty big difference. This is feeling really good, really secure in there right now. I've also done a lot of adjusting of the flathead screws so that they're all at the proper stick out to where when this is in the dock, it doesn't rock. It's pretty solid. This side, interestingly, rocks. So this one needs some more attention spent to the stick out of those flathead screws. But it's still very secure in there. This is doing really good tool changes. Let's home it all. Just wait until you heat the chamber 100 times, the magnets will start to fail. How has that been? So testers with enclosed printers, heat cycling, have there been much in reports of issues with that?
I haven't heard any reports of magnets weakening. I think it really depends on the quality of your magnets. Am I able to share the screen? I'm going to try to do that. I want to show.
If you can share the screen, I can show it.
So there should be a spreadsheet that says magnet testing.
It's going to view a little weird.
I think it's good.
Because it's showing my view of you. So
it's perfect.
You want to click the got it there. I think.
Yeah.
Is that
and we'll be able to
screen
see
or mine?
It's on your screen, I think, because I'm not seeing anything.
Oh boy. Got it. There we go. And can I? Oh.
Bam. Good.
There we go.
Perfect. So you'd ask me, wait, what if I use larger magnets? What will happen? So we built a magnet tester.
Oh, yes.
Exactly for this. Just 150-ish lines of Python and a load cell, $10 from Amazon for 2, super cheap. It's a little bar you find inside a kitchen scale. And if it deforms, it changes resistance, it measures the resistance, and then you can read that with a library for a Raspberry Pi. Anyway, so one of the biggest problems that testers saw is it wasn't reliable. Well, why is it not reliable? And the number one reason is that the magnets weren't real magnets. They were advertised as N52, which is a higher grade, much stronger. So here's actual testing I did. This was before I had done a fully automated one. This was, I think, the initial kind of pull a little magnet on a sled while watching on a fish scale, and then look at the number very closely until it goes. So the number increases, and then it goes to 0 as the magnet pops out. And if you go with Amazon N35s, the 6 millimeter magnets will do 1/3 of a kilogram. If you do proper N52s from one of multiple sources, I tried Fabrico, that's column L here, and I also tried, is it on the screen? Yeah, that's on the screen. And I also tried ones from DFH a while back. And this is a big difference, right? This is 3x the strength.
Yeah.
And they're going to vary between manufacturers. They're going to vary between individual magnets and individual measurements. Some of this variation was from the fact that I was manually pulling, but it just blew my mind. And when you have even very small gaps, this is the other thing in red, this is the air gap. And one of the first things I learned here from the testing was you can have a very powerful magnet, but if you have even a gap of 1 millimeter, you've lost most of the strength of that magnet.
Oh, yeah.
So it's really important to have a little tiny gap there. And the hold force against that head is going to really heavily depend on the gap. Go another millimeter and you're halved again. And so you can go from having a kilogram of force to less than 1/5 that very easily.
Yeah.
And that's why the design tried to minimize that gap, and why the documentation tries to let people know this really does matter. And that gap was so small in the beginning that when the magnet forces were high, they'd actually pull in, because the magnets are on the inside of the Maxwell coupling. It would cause the plastic to bow inwards and touch and then rub, and then your Maxwell probing wouldn't be reliable. So there are all these little things that, things that only appear at temperature, at higher pressures, over time as the plastic relaxes, that make the plastic design in a chamber fun and challenging. And I tested quite a few things. In fact, a friend was buying 40,000 magnets, and he said, "Hey, are they any good?" And so that was kind of the motivator to build the magnet tester in the end and see if his magnets were any good. And turns out they were amazing. You can get some really powerful magnets if you're willing to bump up the forces and put a bunch of them in parallel. And even things like if you have 3 versus 3, the orientations of those 3, whether you alternate north, south, north, it actually matters. So you can get much more hold if you do north, south, north, and the field lines are all circles, rather than if they're all in the same direction, in which case the magnets are kind of pushing against each other a little bit. So I don't want to dwell too far in there. I just want people to get kind of a little peek at just the level of some of the testing that goes into these things to get them reliable for open source. And I don't think there are too many here who are kind of going to quite that level where they're spending a year and doing their own test rigs. But there are a few people in the hobby, I think, that do this level of testing. So one of them is Cloak Dwayne from the Monolith Gantry side, has over 1,000 input shaper tests logged, which blows my mind. I have only 200 something in my folder of those. Right. And I think when you do that level of testing, typically, I think it leads to a much better result. You understand the problems, and then you can understand the solutions. So we're in this space where I understand all the problems of the thing that you built, and I kind of saw some of the problems in advance. But that doesn't tell us what to do next exactly. We can improve on what we've got and make it more accessible, or we can try some completely new things. We can go for speed, we can go for temperature, we can go for quality. We're not done, is all I'm saying.
It's awesome. So I've homed, and now we can go through and show I mean, everybody's seen this, but do a tool change at reasonable speeds.
I don't get bored of this. I hope
I don't
audience doesn't get bored either. You never get bored of watching deltas in motion or tool changers tool changing. Those are the 2 things.
Well, I'm looking forward to the delta thing because I'm building a delta with kiloprints. That's my first delta. Now, I know you have a long history with deltas.
Yeah, the printer that got me interested in printing was a delta. I lusted after a Kossel, which is extrusion based back in 2013, open source delta, made an OpenSCAD. So it kind of looks like Python descriptions of objects. And I remember submitting to Johan Rokol, who had done the Rostock and the Kossel, these early open source deltas, changes to the object descriptions for the little corners to add a hole so that I could more easily get an Allen wrench in there and take it apart. That was the kind of stuff that got me really excited to work with others from around the world, people I'd never met, and do more open source hardware. Like, I'm not in this for 3D printing in particular. It's just fun to build cool stuff with people, regardless of what it is. It just so happens that there are a lot of challenges in 3D printing that touch mechatronics, touch mechanics, touch software that gives you a lot to chew on if you want.
Someone asked how much this cost me, and that's a complicated question, because I took an existing IDEX machine, my Tridex, and converted it to this. And really the cost of what it took to convert this is some magnets, some acetal rods, and fasteners and stuff, and then printed parts. So the cost delta between a working printer and this is pretty minimal. Now, I went with a few other things. I used a couple of Galileo G2 extruder setups. I got the Big Tree Tech donated them, but I'm using the Gen 2 EBB 36 tool head boards, you know, this kind of stuff. Vitali gave me the CNC gantry setup to try out and check out. But just going from working printer to making it even a single tool, because there is some value to being able to take this off and work on your tool head real quick, to just implementing this Mad Max carriage and tool head system is pretty minimal. How do you know what the cost? Because the other thing is Zarancho here gave me the little packet of components to enable this, the pins and the acetal rods, because those can be hard to get in small quantities, right?
Yeah, they can. Well, even in large quantities, they're cheap. I think it was
true. You end up with a lot extra,
which is not exactly a cheap place to get anything. Good stuff though, high quality, and it was less than $10 for the little tiny white pins. You also have to get the metal pins, and so it's one of those things where there are a bunch of little things that you just need one of. It starts to add up. I do want to answer. I was skimming quickly questions, and I saw one about, well, how do you have a quick way to see the strength of a magnet? I do. I can't remember if I released this. This is my little magnet tester guy, and the idea is you put a magnet in here and a magnet in there, and then you stack quarters in here. You just twist them in, and if you can lift 5 quarters, you have an N35 magnet. If you can lift 15 or 16, you have an N52.
Nice.
So it gives you a real quick way, and it doesn't need to be calibrated. It just needs, in the sense that the difference is so large between real and fake that you're going to know pretty quickly. And there's a little bit of a gap here to reduce the force of the magnet so that we don't need to be rich enough to afford a bajillion quarters. Yeah, there's a channel on the Doomcord Discord for Mad Max Tool Changer. Maybe someone should ask about it there. I know I've shared it before. Someone either can link that to you, or I'll get a ping to do it this weekend. I'm catching up on some other stuff. But yeah, this is a 10-minute print-ish. If you have a fast printer, gives you a quick way to see if you have real or fake magnets without needing to buy a kitchen scale or fish scale or anything more interesting, like a fully automated load cell based Raspberry Pi magnet tester.
Awesome. Okay, let me bring up, we want to do a print, right? So we need to get a print started. We can definitely spend all the time talking, which would not be terrible, but let's get the printer doing something. Let me switch over to a profile here. So I think, yep. So I think we can we still hear you? Yes, we can still hear you. Cool. So I am going to, this was a test print I was doing because I was doing some calibration for the TPU we're going to use here today. But the GPs here in chat gave a suggestion for a multi-material print, and one of the big things I want to play around with are multi-materials rather than just multicolor. And the GPs does high-speed fixed-wing drones, and sent me a section of an airfoil that we're going to try printing with a TPU skin, so TPU perimeters and alternate material. And we're going to try PET G first, infill, just to affect a very tough outer layer with a rigid structure to it, and see what we end up with. So we got this shape here with a little live hinge for the aileron, but I've already got the TPU profile in here, and then I'll have to pick some, let's go back, I have something else here. I haven't actually tuned a profile for PET G, but we can throw some values in there that'll probably get us a successful print. Might not be perfect, but it'll be successful, I think. But I think, and I've never done this before, but I think what I would do here is if we go into the multiple extruders, we can tell it what extruder to print infill and what extruder to print perimeters with. And it might be as simple as that. So right now I've got this set to 0% infill, but we're gonna want some light amount of infill. And we go to the multiple extruders now, we can say infill extruder is 2 and perimeter extruder is 1. And at the very basic, we can see some result we get there. Does that look interesting? Now the question is, does TPU and PET G, or does TPU stick to anything well enough to be useful for this? Have you seen anybody else have try anything like this?
I haven't tried that. I don't have a ton of experience with multi-material. I am curious. I think some of the recent Prusa's slicer releases, I remember seeing a feature that would, in the slicer, kind of intermesh, create a mechanical lock.
So let's interlock. Use interlocking depth, Interlocking beam layers. Let's see where this is. So this is down here. Use beam interlocking. Let's see what happens if we turn that on. Slice it. I didn't think it would actually do anything with this. I think if we had two bodies that were multi-material that we were trying to print, it would do something. But I don't think the slicer this is the intended application of that interlocking layers function. So anyway, let's bump that infill up a little bit because it seems a little light to me. I don't know.
What's interesting about this setup to me is you don't actually need interlocking, you just need it to fill the volume. So they don't actually need to be bonded, right?
I think if it's not bonded, it might feel a little loose.
Does the wing need the rigidity for its aerodynamic full lift?
That'd be a question for the GPs, but I would suspect probably. I don't think we need so much. I don't know how big that white tower is. 3 grams. I don't know if we need that much. Oh, something else I noticed after stream last time is I went in here and I changed the retraction when tool. Oops, this is. Let's see. Get this to where we can actually. Everybody can see it. Change retraction when tool is disabled to pull the filament out of the heat zone because it seemed to be cooking the PLA when it was sitting there at the dock, heated up. Now Prusa Slicer doesn't really enable the extra features by default for doing a better job of cooling down the tool while it's docked. It hides that behind having an XL, but there are like Orca exposes that and Boss Slicer exposes that. But I don't have either of those set up for this, so we're just going to do this. The GP says he wouldn't want the airfoil or wing to change shape unless it's designed it for that. Okay.
That's fair. I mean, I kind of wonder if the slicer could have an explicit notion of print outer shells to width in material with extruder. Because the problem, as you were mentioning, is that we only get the infill, but we don't get any outer perimeter walls on the inner material.
Mm-hmm.
So I wonder if more people build tool changers, if we'll be able to push Prusa Slicer types. Exactly, like if we had perimeters for both
layer.
types. Yeah.
Yeah. And I don't think that's in here. Yeah, it would be like print inner perimeter in some material and all other perimeters in another.
Yeah, exactly. And if you had 2 bodies, of course we could do this, but people don't want to mod every file to do that.
So this says it's a 40-minute print, but I think what we're going to do is we don't need this to be 20 millimeters deep for a first test. So we're gonna cut this down to a 20-minute print and see what it looks like. So let's go ahead and I need to put filament in tool 2. So let's go ahead. Tool 1 is already, or tool 0 is already has the TPU in it, and this is Soraya Tech 64D TPU is what I'm trying. I think I can go here. Let's heat this up and get this TPU going. And I picked a nice bright color. This is what color is this? This is electric blue, PET G. Am I the first live stream to feature Mad Max that you know of?
Meet the Makers had it, but that was not while printing. That was walking through the design and being interviewed.
Yeah, I mean, I'm talking.
Yeah, I think you are.
Intended to mean a build. Yeah.
First that I'm aware of.
Hey, Sean. Okay. I'll just use the little knob here to get it advanced most of the way.
I was playing with the magnet tester ring and I got it past a joint and I realized, oh no, it's almost stuck on there. I've got it off.
Let's extrude that. Purge some material. Where's my tweezers?
Yeah, I'll wait till the print gets going. I was taking a look at some of the questions people had, quite a few.
Oh, okay, good. Good things. 65 on the bed. So it's going to be heating up here for a little bit. Go ahead, and you saw some questions you want to answer. Go for it.
Got it. Yeah. Someone asked about load cells for probing. Load cells are cheap. They can be repeatable. They have all kinds of advantages, and that's why a lot of the commercial printer makers are putting them on their tool heads. I would love the ability to automatically dial in a first layer based on pressure. I think load cells would be an amazing fit for this printer because right now it's a high force head with Maxwell probing. Mine, not yours, the default when you have the whole head slide, because we need a lot of magnet force to hold the head, but we don't want to reduce that just to get a lower probe force. And so I think load cells would be great if we had some hobbyist options for them. I'm aware of some work in the background, and I know there's some commercial versions, so I think that will come out at some point. And I know Gareth has been doing some great work to get that into Clipper as well as Calico lately. And the next closest, I think, is the PZ probe it's a low force probe. So we're talking grams more than a kilogram-ish, which is really good because I always found that with high force probing, eventually your set screws, if you have belted Z, get loose. And it just kind of pushes on the frame of the printer a lot more than you'd want. And that makes it also harder to get really good repeatability. You may have to slow down your probing or make sure everything else is really tight. And also when you've got belts, that first hit tends to stretch them a bit. And so you lose your first cycle because you're just stretching your belts because you're applying a lot of force. The lower the force, the less the stretch, the more repeatable it should all be. Are we still heating up? Got plenty of questions.
Okay, go ahead. Keep going.
See, I'll go in the order that I find interesting.
I'm basically going to start a print here, so there's no reason for me to interrupt while I start the print. So
yeah, I'll clear out some of the question answers then. One person asked, is the HUVUD still usable? Absolutely. All these parts were printed with HUVUDs, and this has a HUVUD inside. Actually, the HUVUD is the first tool head board I started with. That's why I got kind of trapped in the local minima of 42 millimeter tool head boards, either EBBs or HUVUDs. I don't like the little tiny connectors on the HUVUD, so I wouldn't buy them anymore. But I've got a bunch of them, and I still use them. And they enable a very compact head because unlike the EBB42, unlike this one, they don't have a honkin' Molex connector on the outside. They have the smaller microfit right there, and they don't stick out nearly as far. So it's like a 5 or 10 millimeter gap in front, going for an EBB42 to fit the stuff sticking out versus a HUVUD. So I hope to see innovation in tool head boards to keep them really tight and maybe think more about integrating them with the tool head, possibly all together as one to use it for the frame. A few people asked about CNC. I think it's a natural thing now that CNC is going down in price. I haven't personally done that because I don't have access at the moment to a mill. I live in a shared space that's fairly small, and at one point I actually had my little desktop Shoreline. Yeah, there's one of the tool head boards. That's a HUVUD with a little black microfit. Yep. Yeah, it's a fine board. I did a bad thing with the HUVUD creator. I asked him to put an 80XL on there because I had shown that the pins were already there. I modified mine originally back in 2021 to add an 80XL on the tool head, but it was using the pins and then having a separate mount on the carriage. So it was a really good carriage mount. You could trust the results for input shaper. problem with, especially the little 2-pin on the motor tool head mounts, is that they can act as their own springs and they can flop around. So I personally would not trust those results at all. I've done those measurements of measuring at the nozzle, the carriage, and the tool head. And unless your tool head is extremely rigidly supported and your tool head itself is very rigid to the carriage, you're going to get completely different frequencies versus other places that you measure. So I apologize for pushing Pontus, who's the Huva board creator in Sweden, for that, and all the people that followed with it. It's not a terrible idea. It's just not a great idea, let's say. And I personally try to measure at the nozzle as much as possible now, because I think it's the truest reflection of the nozzle's experience for vibrations. So if you're going to cancel out vibrations, it should be what the print's actually doing. And the nozzle's the best choice. Carriage is second best. Tool head is third choice, but only if you have a super rigid tool head. All right, I see some motion. I see a tool head homing. Does Y then X. And then it's coming out and it's doing the home on Z. Okay.
I'm just reinitializing things.
All right, so now
it's up to temperature.
Doing its Z tilt. So someone asked about MMU on a tool head. What do you think, Steve? Would you put an MMU on a tool head?
I want to do that on here just because. Not because I need it, but because I want to try it. So I want to put a multiplexer of some sort onto tool 0, which leaves tool 1 for an additional material, whether it be supports or another color or whatever.
I think that would be an amazing way to go. Because if you're going to build an MMU, you potentially have a way to keep your filament nice and dry, to press a button and get exactly what you want and be what I call lazy mode. That's kind of why I want an MMU, not to do multicolor, prints or endless spool, just because I want to be lazy and never have to move filaments once I put them in. There's like a smaller set of filaments I tend to use. And then with the ability to do supports as well, you're covering all the use cases right there. It sounds great. And you're not adding the complexity and the extra cost of having all of those extra tool heads and trying to find a place to fit them and manage all of the umbilicals. You don't even have a top hat on this thing, but you've got your wires nicely managed. And that's kind of one of the unique features here.
Yep. So I do expect to end up with a big Tridex Vivid. So that's what I think I'm going to try on here. I had intended to move my box turtle to here, but my box turtle is working on another printer. So if I got another device coming in that does that, then it gives two reasons for that. It gives me an opportunity to check out a new thing, and also gives me a project to try on here.
So the only problem would be if you put it on head 1, what if you want to use 2 colors and never do any MMU motion at all? What would you do?
So the what? 2 colors and never do MMU motion? I don't know. If it does the well, I guess that would completely depend on the macro setup, the configuration setup, on whether you can do that or not, right?
It would depend on the macros. It would depend on the physical setup as well, right? So if you want to have like a bank of filament and then you have a bank of heads, maybe just 2 heads to start, so that you can do a print that has no MMU usage during it. That would be a challenge because you need a way to route each of your, let's say you have your 4 filaments for a box turtle to each of your 2 heads down here. So you need a multiplexer that converts 4 into 2 and kind of routes a filament.
Yeah, well, I would just run it to 1 tool head. Now,
yeah, I think that's where the software support's starting. I think people have done that. So Patricius or PTR, I think I've seen a YouTube video from him of a tool changer plus an IDEX, I think it was an IDEX with an MMU attached. So you could do N+1. You could also potentially do N+N if you had 2 distinct MMUs, but then the problem is if you want one print that uses the 2 on the left or the right, you're kind of stuck. So if only someone had done something for that. Yeah, someone in the chat knows what's up. So at the very end of the Mad Max stream, there was a one more thing. There are actually 2 one more things. One is really cool. Vlad showed off how to use an eddy sensor turned upside down.
Oh, right. I'm really interested in that. Yeah.
Nozzle offset calibration as a replacement for nudge that doesn't have any of the mechanical considerations we talked about earlier, right? You literally just buy an eddy, you flip it upside down, and then you run this code, and it seemed to do very well within the range that I think would be useful. I think it was like 0.02, 0.03 repeatability, which is, I think, good enough. It's a great starting point. It's probably better than you're going to do manually. And if you get that automatic, you're good to go, especially for print. There are a few other things like to replace a nudge. There's something called ball probe, where you have a sphere and then you suspend it on a spring. And then as it moves around, it breaks the connection. That was the original one that Vsters had done the code that I ended up using with nudge for. That's all part of the Clipper tool changer stuff from Vsters there. But where I was going is the other one more thing on the Mad Max stream is an M2 filament multiplexer. So it allows you to have your single shared bank of filament, and then mechanically through a sequence of valves and different ways to build it, route any filament you choose down to the left or the right head. So if you had an IDEX, a dual gantry, or a tool changer, or even a single head, kind of like the H2D that has 2 hot ends, 1 tool head, you'd have a means of routing exactly what you want down to the head that you're interested in at that moment, so that there's no mixing between them. It has a secondary benefit. This concept I call a DOMO, a dual output MMU, but it's really like a dual output selector. It's just a piece of the MMU. The rest of it is stuff that winds the filament from the rail. And then there's also like a piece that merges all the outputs. And the two methods are, one is you have individual little filament valves like on an engine, where you have filament coming in and either goes up or it goes down. But if you have a little valve that redirects it as it comes in, and then you can move the valve and then it goes down. That's the core concept. So if you have a bunch of those and you put them into a Y combiner, you can route one Y combiner to the left and one to the right, and there you go. The other design is where you have a linear rail and you have selectors. And so imagine you just have like a little Bowden tube. So you have your inputs coming in, and then you want to move your selectors, and then each one goes straight to the head. So the problem is they're going to kind of smash into each other, and you want to be able to have any input to any output, even in the middle of a print, so that you can use 3 filaments with 2 heads, and then while one of them is printing, the other one can be changing, priming, purging, whatever you need with it, and then getting ready to go, and possibly even completely hide all the switchover delays from the MMU as it's moving filament up and down, and then doing the purging to get ready or the priming to get ready. So that's the other concept, which is you have selectors, 2 of them on a shared rail, and then to have them pass through each other, I'll show with my fist here. If each of them is spring loaded, then when one comes by, it can move on the spring and then pass the other one. So each of them can move up halfway, or when one of them is kind of locked in because it's feeding filament, the other one can swing all the way out of the way. And that means that you can alternate between any filaments, any head. It's pretty fun. It's called like a dual output MMU, and I showed some video of that at the end of the Mad Max stream. It went long, about 2 hours in.
So I have 64D TPU in here, and it has a relatively high melt temperature, and I think there's a bit on the tip of the nozzle that did cause that mesh to fail. Too many samples, or samples out of range or whatever. So it's going to redo the mesh here. Hopefully I cleaned it off enough to be okay. We shall see.
When I see your printers printing, I remember some of the things that big printers need that I've forgotten in the last few years.
As in, like what?
The mesh.
Oh, wow. Good point.
I used to have a 1 meter delta for a while, and it would do a bed mesh. It would do the center, 6 points in a ring, and then 12 points in a ring. This was with rep firmware. It's like 2016, 17. It had the Duet Smart effector, so it had an integrated strain gauge load cell effector. The actual circuit board had little metal traces, and as the effector would push up in the center, it would stretch the entire flat PCB effector. It would measure the change and very reliably detect where it was. The only problem was I had a big DC bed, and so the DC bed would induce large enough currents to trigger to modify the measured resistance. It would do false triggering, so I'd have to shut off the bed heater, do my probing, and then turn it right back on after. Little quirk of that Delta setup.
Let's put this in for a little tighter shot when this goes to print.
Yeah, I heard you like MMUs, so I put an MMU on your MMU. Not quite, but in that direction. So the small asterisk is for that is I haven't released it because I want someone else to do the macros for it. And there's like the 10% that always takes the 90% of just the fixing the little things when there's other stuff in view, like Mad Max development that I think would be more valuable in the short term. The other thing, the other asterisk is it has no macros or software support. So you would have to be a Clipper Ninja to get the thing working. One hell of a Clipper Ninja. And that's not me at the moment. So it's one of those ideas I've shared, but I need the right partner to make it work.
This is still running Joey's print start and priming stuff, so it's gonna do some logos in the corner, and I'm going to, because this is a TPU and it's gonna string all over the place, I'm gonna kind of babysit it, grabbing the. Oh, okay. I'm just gonna grab that one first. Do I have it still set to prime all the nozzles? Apparently. There we go. Get that out of there.
Yeah, solving the problem, then it's not as interesting anymore. Agree with that. JV says 1 night of config and tuning from the README. That may be a little aggressive, but I didn't specify the length of a night. But also, if you already start with the tool heads and your bed's in a reasonable spot and you've got a nudge, I think it actually isn't crazy that you could build a carriage pretty quickly, and you could build 2 plates pretty quickly. And then if you've already got the tool heads ready to go, then it's mostly installing Clipper Tool Changer, finding the extents, and then swap it in the macros. I think easier macros that are better explained and just kind of the checklist of do these things might get us a meaningful step to shortening the average time to get things working. Steve, you've kind of seen it. You know that it's not done, but there's a lot of documentation, but maybe not enough. What would your take be? What you've seen?
I think it's really, really close. There's the things that we're missing, if I remember right, because that's been several streams now. We're more just nitpicky things. I could go look up some fastener size or whatever, you know. I don't remember any major omissions.
Yeah, you'd mentioned some times where I said, use the Maxwell screws, and you're like, what are the Maxwell screws? And I'm like,
oh, wow.
I know what the Maxwell screws are, but I didn't explain them and I didn't add a diagram. And I shouldn't say use the Maxwell screws. I should say use the M3x8 button head cap screws. There are 2 of them, you know, things like that.
Yeah.
That would be easier. I think that's the next level for it. Okay, I'm seeing printing motion.
Yeah, we've got things printing. Definitely interesting in the tuning of stuff. I think if I started this over again, I would probably increase my extrusion width for infill, just to make things a little thicker. Might change my like first layer squish or something. It seems to be doing okay. We'll
All right,
see.
so we've got our little prime tower in the back right.
Yeah,
and
that's
we've
not
got
where I
our-
would normally have put it. I got turned around in the slicer, I think.
Yeah, it's just adding print time delay, and it's
Yeah.
increasing the chance that, you know, you don't want to go from the dock over to the prime tower. You want the prime tower pretty much right near where the nudge is. Minimize the or as close to the part the part you're printing as possible, but in front of it and
front,
equidistant.
In between the docks and the part.
Yeah, it looks like a few people are just joining. So we're doing a plain wing with a mix of materials, soft on the outside and hard on the inside. The opposite of candies that we'd want to eat.
Yes. Well, Like peanut M&Ms.
I guess that's a good example.
Although I prefer peanut butter M&Ms. TPU on the outside, yep. Is there a way to use a prime tower with different size nozzles? I have no idea. Yeah, I've got some filament bunching up. We'll see how it goes.
Someone asks if it's going a little fast for TPU. I'm curious what speeds you tend to print TPU at.
This is 64D TPU. So the it's a lot. It doesn't get bunched up in the tool head. It's 64D, not A. So it's like the equivalent of, I think, the 115A. So you can get away with, I think you can get away with a little faster print speed on this. The slicer does not support separate prime towers per material.
I wouldn't think you'd want that because the slicer tends to do 2 layers on the same head where possible.
Mm-hmm.
So you don't necessarily have that opportunity each time to, you don't expect every layer to be on the prime tower with 2. You're kind of alternating each one. I think it's tool changing pretty smoothly, I gotta say. It seems like those magnets made a big difference, and that little bit of extra force seems to make everything feel really solid. You just gotta get beyond the margins, and you're right on the edge with those margins with your beefy, heavy tool heads.
Yep. The only thing I feel like I have to tune is the screw stick out on this side, so it doesn't rock. This one's solid, and if that didn't rock, then I mean, I don't think the rocking is really hurting anything, but I think it could be just a little better.
Yeah, it's designed to be tolerant to some misalignment, and the effect of that is the ability for it to slightly rock as the head is pulled in and out, because it's going to want to twist if there's extra gap within the keyholes on the dock. There were 2 questions earlier I want to get out of the way before we forget, and then we can go to some newer ones. Someone asked about acorn nuts. I'll just plus one.
I saw that.
I used acorn nuts to try out an early kind of nudge alternative. If you take, I mean, there's one design called sex ball, and you take a sex bolt, so a male-female screw, and then put a ball on top, like a sphere with a hole, and that will actually work. The nozzle kind of slides over the ball, pushes it down, and then if you've got a switch there, you have a means of doing XYZ detection of offset calibration. I found that when I use chrome-plated screws, including acorn nuts, the chrome plating would scratch off, that it was like a surface plating, and the hardness of the nozzle, if it was a harder nozzle especially, would kind of win. And that was part of what motivated nudge. The other thing was it would take up more space in XY, and the printer behind us is the reason nudge is as small as it is, why it defaults to a 3mm pin, because Steve had 7 millimeters of over travel and back, and I wanted to fit it in back. And before it was 9mm with a 5mm pin, and I moved to 3mm and I got it in 6, because it's just a little bit on either side of the nozzle. And it turns out that none of that mattered because you flip the bed around. But it means that in very constrained spaces like V0s, nudge is one of the smallest over travel required offset calibration probes. And it has also the benefit of the metal part, which is next to the very hot bed. The plastic that connects to the metal part is very far away, so it tends to be more temperature tolerant than something that forces more plastic to be kind of enclosing the screw and right up next to the bed. And there's no worry about the slop of a sliding bearing like you see with our ZN stops. I mean, if it's just probing in Z, you don't care, but if it's kind of pushing left and right, you probably do for the accuracy of the XY. Yep. So that was part of what motivated Nudge. And then one other question, could you use conductive filament for the electrical connection? Maybe. But I don't know that I would trust it. So you could use that on the carriage.
It's still a high resistance isn't it?
It is, and we've got other sources of resistance here, right? We're abusing components for fun and profit. We're using screw heads and pins that are not designed to be precision, repeatable electrical components with low resistance. You know, they're not designed for it. So I would say maybe that's not the best idea, because from what I can tell, the electrical conductivity of like carbon PLAs that are made for that, or others are already pretty high resistance. Like, yes, technically they're conductive, but I know that they're usefully conductive for this application. But I encourage you to try it and see what happens and report back either way.
Typically conductive for static dissipation, not necessarily for circuit integration.
Yeah.
Go
ahead.
I was just going to say, someone asked why this printer exists, or why I changed from the Tridex to TriMax. And there's two reasons, or probably more than two reasons, but one was I never really got my Tridex to work great, and the offsets were difficult to keep consistent. I had non-Tridex related issues in the controller early on, which made it difficult to get the motivation to work on it. And probably the biggest reason I converted is because I wanted to try Mad Max, and this was the best platform I had to do that on. So
yeah, I think the offset calibration is really critical here, right?
Mm-hmm.
You need to make sure your nozzles align, whether you have IDEX, tool gantry, 2 hot ends, 1 head, or tool changer here. And if it's off even 0.1 millimeters, you're going to see it. And if it's even 0.1 in XY, you're going to see it at every seam. And if it's off 0.1 in XY, it means that your stacked layers, even if your Z alignment is perfect, even if the heads have the exact same Z height, if they're off slightly in XY, what you find is if you print something like a simple cylinder, when you rotate it, it changes color.
Mm-hmm.
And the reason is that on one side you have droop that makes one color be more visible, right? One side, if it's farther over, it'll droop down slightly and it'll be more of that color. And on the other side, it will be less of that color. And as you spin the parts, if you do something like green and silver, it'll be more greenish on one side and more silver on another. And if that offset is changing over the course of your print, which it will as your frame expands and as it gets to temperature, unless you wait a long time, I think that appears to be the issue you had with the Tridex. You can't guarantee, unless you continuously re-offset calibrate in the middle of a print, potentially, that your print will remain the same quality as it progresses. And that to me seems like a risk that I wouldn't want to take.
Yeah.
Here, we don't expect that to change because it's only the motion within the head. So there may be some motion within a print as some components, get hotter than others, but those components don't heat up as much, for one. And the second thing is they should all be the same. It's not the full frame expansion you need to absorb and all of that XY variation. It's really just what happens within the tool head. And if you have a fairly rigid plate and hot end, it's just that connection which can vary. And that's going to vary much less than the entire motion of a frame. It's that X distance that I think is the issue. Now here, I don't know if you've enabled it, per print probing.
I have not.
I think it's really interesting. So Joey, who goes by R2PDX on GitHub, showed macros that enable you to do per print probing. And we do that with bed mesh. We do that with Z-tilt. We do that with homing. Like, we do that with all kinds of stuff, but we don't do that with offset calibration on printers with more than one head. I think it makes sense. You just got to absolutely be sure that every time it's going to work. So just like with the Z probe that isn't perfectly reliable, it's going to get annoying pretty quick. I think it'd be even more annoying here, because if you don't get that offset consistent because there's gunk on a nozzle some of the time your prints are going to be off, and you'd rather have a bed mesh fail than have a print go wrong and discover an hour later. Right. So I think the key is the probing method either is not sensitive to crud on the nozzle, like Eddie's method of the flipped over, not Eddie, Vlad's method with the Eddy current sensor flipped upside down. Right. Maybe it doesn't care about crud on the nozzle because it's looking at metal as it moves around. So that's a great idea for just that reason alone. Having more force may actually be a good thing for Nudge than to dislodge any crud and be more consistent. But I think a nozzle cleaner or just getting out a brush manually, if it's a print you care about, I think that's a really important thing to be aware of, that you've got to have a clean nozzle if you're physically using the nozzle to figure out the offsets and find the center.
Yes. Yep.
And this is going to apply if you have a camera as the method of that as well. Like whatever method, as long as the presence of the crud may affect the calibration,
Yep.
you need to remove the crud. And the crud, I think, would make the camera calibration actually worse over time. It's very hard to get a very clean picture of the very center of a nozzle. But it does have the benefit if you've cleaned off that nozzle and you just need to look for the center and the rest of it is very reflective around it. It's a non-contact method, and it doesn't depend on, in this case, screw conductivity.
I did reach out to Vlad to see if he'd made any progress on that, and it's dropped to lower on the priority list. So hopefully at some point someone picks it up or it gets worked on again, because that's really interesting.
Yeah, for what it's worth, all the prints I've ever done have been automatically calibrated with more than one head on Mad Max, and I've never printed one of those Vernier XY calibration prints because I don't have the patience for that. And I know that the moment I change my printer and the moment I tighten a screw on the hot end because it got loose on one head, I need to recalibrate at that point. And I just never wanted that issue. And so everything I've ever done at this point has been with nudge. And the key is you need to have a good mechanical and electrical setup with it. And then once you have that, you need to probe in the environment in which you're printing. So probe at high temperatures and probe with a clean nozzle, and you'll have no additional offset. But the difference between cold and hot probing, it's just like with nozzle offset calibration in Z, there's going to be a difference because that head grows 0.1, 0.2 millimeters in Z, and it's going to be the difference between etching away the PI in your bed and having a first layer if it's, you know, your nozzle that you didn't calibrate hot. I did that recently personally. I have a Voron cube shaped shiny metal mirror in the middle of one of my otherwise brand new build plates on Monolith Zero because I made that mistake. It's the same thing here. You want to probe in the environment that matches your print, which means bring it up to temp and then do it. Because that 0.1 millimeter offset will be the difference between a part that looks great and a part that changes color as you spin, but you didn't want that.
And just a quick note, I know some people have been asking in chat, I'm not cooling down the nozzles right now. They're remaining at full temperature. Now I've told the slicer to retract the filament up out of the melt zone while it's sitting at the docks, but it's staying at full temperature.
A lot of us have the Voron cube shaped etching on a PEI sheet somewhere. I should be happy that this is the first plate that I'll ever have to retire because of mistake rather than wear. So I guess I've done well. I've been lucky.
So latest question there from Zachary. I own quite a few Prusa's, Zachary. I have two Core 1s, a Core 1L, a Mark IV, a Mini, and I've had Prusa's since they pre-order of a Mark III. So I have a long history of liking these build sheets. Yeah, the ooze blockers do seem to be working pretty good. Especially, I mean, the evidence by the TPU side isn't, there's very little. There's a little bit of stringing along there, but not as much as I would expect.
I wonder if you're able to zoom the camera in towards the print and the ooze block and give us a sense of kind of what we're seeing. And if this were CSI, I'd say, can we zoom and enhance?
Hold on. For some reason, this camera needs to be reinitialized occasionally. We should get a good view here in a second when this comes back up. This is the zoom blocker.
I'm leaning in as if that's going to give me more pixels.
It's an untuned print. It looks like I skipped some layers there. That's interesting.
I wonder if the TPU was is getting hot and got ground up in the extruder, but then resumed.
I don't know. We'll do some. I think We may be able to get another one of these in. So the print time estimate said 20 minutes, but you can do, if we go over here to the slicer, under filaments in the advanced section, you can tell it how long your tool change is going to take in here. And then that'll calculate that into your print time. So we get around to that, actually timing an average tool change can be put in there to help.
Yeah, it's something to point to people who are just seeing this for the first time and joining is step one is make it work.
Yes.
We're trying to get to a reliable print that tests new materials and tests their interactions with the slicer, where there's a lot that can go wrong. We're also running the whole tool changer at uber slow speed to have giant margins. And then we'll crank everything up as we, step one is reliability, step two is perfection, or at least a pretty print. So if this finishes, that to me is a success. That's kind of how I tend to think about these things when it's our first time doing it. We're testing whether the little silicone strips, the ooze blockers, are working. Mm-hmm. We're testing whether we can have a purge block made of two materials. We're testing whether the slicer can actually drive this printer in a way that gets us the print we want.
Yep. Hey, Vitaly.
There was one question earlier about, are you improving the dueling zero? The dueling zero is two distinct gantries in one workspace, which means they can pop heads and destroy each other, which makes it a very exciting time every time there's a print and they're both in motion. It also means that you don't need to design a tool changer coupling. Past me was very excited about that. And it also means that you can do copy and mirror modes, just like an IDEX, and actually have more flexibility there. Potentially even two prints at the same time or multiple prints at the same time, just as long as they align at the Z, or you add a barrier, M400. The downside of the multi-gantry approach is that it's double the complexity of all the stuff that adds work. So it's like, in my case, it was 1v0 for the price of 2, which isn't so compelling to most people, and building a community around it, I'll admit that. Also, you have to sign up for an entire set of completely new calibration challenges, and most people don't want to willingly sign up. Most people would not consent to signing up to completely new methods of calibration, because you can have all kinds of skews with gantries relative to each other. Mm-hmm. Those are reasons I have not spent as much time on my dueling zero lately. I did one version which worked. I did another version that was, I think, much better designed. I still use it, and it's been my daily driver for almost 3 years now, and it printed a lot of the parts that you saw, most of which had a Mad Max coupling because I was dogfooding it. Works fine. I still use Mad Max Maxwell probing, and then after 50 to 100 hours, when I start to see a little bit of degradation in the probing quality, then I'll just switch out the 2 lower screws, and generally it goes back to 000 probing. Okay. So I've not had issues with it. I think it's screw wear that I'm seeing with my particular metal screws on the hardened steel. So I think the soft part wears, and then it gets kind of flat. And then if you don't have the angle, then the coupling's not going to repeatably reattach. It ceases to be a good kinematic coupling if you don't have balls, you just have flat things next to the pins. So the question is, should I waste any time, or should I devote happily time to making it a better thing? Given what I just said, you probably know my answer. I think it's the coolest freaking printer ever, but just second to Gus Simpson. Look that one up on YouTube. But I'm personally not putting time into it, because I'm putting my time into stuff more like what you're seeing on the screen in motion right now, that I think is more broadly applicable. Things like Nudge, things like Mad Max, things like Speed Clips.
Speed Clips is cool. Question on the silicone material. It's just a sheet, high temp material with strips cut out of it. And then there was another question on PLA PETG Purge Tower. My index machine is actually printing a 3-color print with PETG supports, and the Purge Tower has been the least of my worries on that print. So it's loose.
Oh no, again.
Did it come loose? Huh? Purge block.
I mean, I'm surprised it's gone as far as it has, because it's to similar materials that aren't necessarily going to attach.
Oh yeah, it is loose. Okay, well, I'll go ahead and cancel this. We're most of the way through. We've got we've got information on this one now. So let's just pause this and cancel it and see what we got. It's not there. Let's go here. Let's pull off our little, let's see. Just quick check. This is holding together way better than the PETG PLA ones, but you can pull it apart. Let's see what this looks like.
The question we got earlier about, can you do distinct purge blocks? Maybe this would be a really good use case for that, even if you would have to, you would be spending twice as much time on the block. Well, I mean, I guess you need to prime every layer every time you change, but you'd have to have each one go every layer. So you'd spend twice as much time priming. You'd waste a little material, but you'd have a reliable print at the end, which probably matters more. So now I think that's a good idea, when before I might have poo-pooed it.
Yeah, doing this again, which I think we should. I want to change the infill extrusion width and maybe the exterior too. I might make the exterior single perimeter over extruded and then increase our extrusion width for the infill as well.
Is that TPU attaching on the outside?
It takes a little bit of force to pull it away, so mostly, but not fully. We can peel it away. Yeah. There's a cubic infill.
I mean, I guess the alternative would be to do 2 prints and then combine them in post, but that would be a hard TPU print because you'd have a floppy material getting tall. The advantage here is you're using the infill to support the TPU printing. So in general with TPU, this is like a way to, this is a very interesting use case, right? You're improving your reliability of tall TPU prints by having a rigid skeleton for them.
I wonder how strong that would be holding together if it was fully encased, like it will be as a complete part instead of.
Yeah, I wonder if you can do low infill like you've done as the skeleton, TPU as the flexible outer, or the outer with the properties you want. And then if you could combine that with foam or something like that, maybe it would give you the rigidity that you didn't have from just the TPU itself when you go to put the foam in.
I want to try this. I am gonna slow it down. I know I saw that suggestion. Let's see, what was I doing? Print settings. I did want to try, because I kind of want to see what this looks like. Single outer perimeter, but with a high perimeters. I want to do like 0.8. And then infill. Let's go. I mean, I want to just do 0.8 on all of it. Infill and perimeters overlap. I think we could bump that. Infill and perimeter overlap. Let's just see what happens if we bump that up. And speed. Yeah, we'll change our speed by changing the TPU max volumetric speed. See what this looks like when we slice it. We need to increase our, because we changed our extrusion width on the infill, the percentage needs to be changed. Let's see what that looks like. Yeah, that looks decent. Okay. What do we got? Challenge me to ensure you can control the print order in the slicer. For which thing? What was the question on that one?
Yeah, the question I was responding to is about, could you do multiple separate prime towers? And I was remembering then that I actually did that in the early days of Mad Max by having a cylinder in the print separate from the main print, one of each color. And that guarantees that every layer you get some priming. And then if you don't actually do a prime tower, you just prime into that specific material you've got and you have them both right next to your print, you don't have to worry about layer adhesion in your prime tower. Bit of a hack. You have to make sure the order of printing has cylinders before you have the main print to hack a prime tower or two of them.
Okay, oops. What in the world happened there? Let's do this again. This one off. And we can just send it. Might be waiting for build plate temp to settle, I think.
I think this view of the printer looks pretty good, and I think if people really appreciate the aesthetics here and the care paid to your docs and the rest of the build, they should let you know in the chat. I think it's a pretty good looking printer.
I'm pleased. I'm really pleased with how it turned out. And I'm really pleased. I mean, already I've had more success than I had with the IDEX setup.
Maybe you can show people who've just joined the little filament, the ornament that you had done earlier.
Yep.
I think that's pretty nice.
Must have been reading my mind. This was Sunday's print. There we go.
That's pretty good.
Now I didn't clean my build plate well enough, so it curled up and created all kinds of a mess on this side. But this is the key part, is the offset seemed dead on.
So no manual calibration at all there.
That was all with nudge.
Sweet.
See you, Neil. Let me know, Neil, if you're still around. Let me know what you think of that print and if you want me to try anything different.
Are there any filament giveaways today?
Yes. So I didn't mention that at all. In about 15 minutes. So we're going to keep this to a little over 2 hours today. That's including the filament giveaway. In about 15 minutes, we'll give away a roll of Polymaker filament. Links in the pin post and the description. Good reminder. Oh, what do you got there?
People were talking about how pretty your printer is, and I was agreeing. And I want to show people the printer I was hoping to get working, and your streams have encouraged me to revisit and try to improve on.
Awesome.
So I'll set it down and flip the camera here.
Yeah, I'll give you full screen.
And drop my blur. Yeah, so was it December 30th, 31st of 2021, I think, released an IDEX for a V0 in this exact printer frame. And then 6 weeks later, I put it in the cave and never touched it. 4 years later, it came out of that cave. And Mad Max is what motivated me to do that. The one that I had been using was a little 120 by 120 bed Tri-Zero. And with that IDEX, I didn't use it because I didn't have something like Nudge. I didn't have a way to do the manual calibration. I thought, it's a Saturday morning. I don't want to do calibration. I want to do printing, or I want to do design. So that was always for me the demotivator. But now that we have automatic calibration and we've got, these are the heads from the other one that I ported over. I de-IDEXed it just like you did. So it used to have a bunch of extra parts. You can still kind of see the vestigial holes for where the extra belts used to run along the top and bottom here on the sides. And it simplified the back. Instead of 2 motors, instead of 4, I've just got the 2. I haven't actually touched any of the wiring in 4 years, but it turns out an octopus is still a good choice. And yes, I spent some time on the wiring, and it's a lot cleaner than it used to be because I used to have a motor here and a motor here to do the Y-assist belts on the IDEX. And this is Tri-Zero as well. So the idea is to take the parts from a printer that was becoming a rusty dev claptrap of a green Tri-Zero and put the parts into something with a wide base. Someone had mentioned in the chat that the perfect frame for this tool changer is basically a Tridex frame. It's wider than X.
Yeah.
I think it's a good choice because I like being able to see what is happening. I like not having to rotate any components. And if all you're doing is widening it, then it's just the base plate and the top plate and the front plate that need to be redone. And if those are boxes, then that's not typically a big deal. Oh, and a wider extrusion for your bed if it's something like a Tri-Zero. So this is the printer that I want to get running as soon as possible. This has a Mandala Roseworks bed in there. This really nice 220 millimeter wide, I think, or similar, close to that. But this is a bed that's not it's not full width. And so right here, you can see it. That's where my nozzle tip is. And there's a little bit of clearance there between the nozzle tip and the end of the bed. So I have space for brushless blockers. And what I have at the moment are the ones from my Tri-Zero, these fold out brusher blockers. This is a feeler gauge. And it's actually tunable, right? So I think you added some washers to adjust your height of brushes. Mine I can tune in situ. I have a set screw that I can adjust again in situ. I don't have to take anything off, and that pushes this metal piece up and down just very, very slightly as a lever. So I can precisely tune the force I want on the blocker. I've got the Bambu Lab brushes in here. I didn't cut mine or trim mine. I'm using the original screws that they came with, just straight into plastic. And this whole thing just folds out of the way. So on the Tri-Zero, when you look from the front, you had no idea it was a tool changer when there was one head, but then you add the second head and you're like, oh, that's not a typical Zero. And then you add your brush blocker and you're like, oh, that's not a typical Zero. It's the problem I have with these is, and the reason I got to redesign them, is that this bed is longer in Y. It's a little deeper. So it would get melted immediately. And I don't have extra travel here in Y to deal with that. So I think what I'll do is something kind of like what we talked about it on the Sunday stream. If we take here, I'll use the other one. If we take the little brush part and we instead, we have it in this orientation.
Yep.
So it's a long Y. Then I would have enough space because I'll move my bed back up to show. That's the other thing I don't like about this one that I got to figure out. This
the top hat.
Top hat likes to pull apart, and I've got all the parts to make it a box Zero, but part of me wants to not change things if they're not going to change the performance. This will just be like a PLA tool changer to play with, and I want to test some of Joey's macros and maybe update all the instructions so that there's a minimum of things to change, and this is the platform I can do it on. One other interesting weirdness about this one is it has 2 100-watt heaters, and I just need to join those wires in the Tri-Zero Wago holder there. But yeah, I think a little brush blocker that's using the Y motion to clean it and blocking it otherwise, either with the silicone bump like you've got or the feeler gauge like I've got would be good. But your silicone strip, I think, is more adjustable. It's cheaper to fix. It's easier to source. Takes less space. So I think that's the design I would want to go with preferentially.
Cool.
So yeah, this is the printer that I hope to hopefully soon turn into a functional Mad Max. And right now it does have the downside. I realized one thing I missed is it's using the Vampire Bat XY joint replacement. So these are actually V0.0 PIF parts that haven't changed in 4 years and they still work fine, but they're with XY joints that look a little different with a front facing rail and a V0, which enables you to use Mad Max tool changer coupling.
Right.
So there you go. It's just like the one you've got, except I have an MGN 9 rail instead of an MGN 12 rail, but very little changes. And it's all done with Fusion configurations. Yep, I got it. You see why it didn't fit in there, because this little extra wire that used to be needed because we had 5, the prior tool heads were old V0 tool heads that had the 5 volt. I don't need that anymore, so I could just cut that off or I need to tie it behind. But yeah, I think this will get me started, but unsupported rail being that long, 300 millimeters instead of 200, I think is more than it will be happy
Not
with for
ideal.
high speeds. So I want to play around with some backers, and if I like it, if I use it, then, you know, we all have our upgrade plans that we'd love to do if time were no issue. I've been playing a lot with Monolith Zero lately, and it has a gantry that I think is something special in terms of rigidity and performance. So I'll flip my camera back.
Yeah.
Yeah, so I think in the long term, that's what I want to do. I want to put a Monolith Zero gantry on there because I think that would give me higher speed for the tool changes and give me less stringing. But should take it one step at a time, you know, get reliable printing. If I like it, maybe add a backer. I'm thinking Maker Beam, the 10x10 stuff might be a perfect choice.
Mm-hmm.
To give it just enough rigidity. And it's just then a part that requires no precision machining. You just put the nuts in the back. Seems pretty good to me. Or even 1515 would fit there.
Right.
But yeah, this is a downside of the design. If you have a top rail V0, you need to apply a mod that gets you a front-facing rail, but all the other printers have a front-facing rail.
Right.
So that's actually, I think, a good thing. It gives you a lot more tool head choices. And I think it's also a technically superior design because instead of the belt forces being far away from the carriage balls and creating an offset that kind of twists and rocks the head as it moves an X, those forces are much more in line when you have a front-facing gantry with belts that are right in front. There's no offset, or the offset is only in Y, which is really tiny.
But you lose some Y travel then, in that case, right? On a V0?
I think it's like 117, 118 millimeters. And if you,
so not a lot.
If I were to modify the Box Zero XYs that I did like 3 years ago, I could get that back, probably then some. It's one of those, I didn't care about those 2 or 3. If you do care enough about it, you'd probably have to modify the parts, or you would, you can get some of the travel back because if you have a non-flush front panel, like if you use zero panels or if you use a colony clacker door, that gives you extra clearance in front.
Yeah.
You can actually have the tool head go beyond the frame boundary. And that's a way that you can get some extra space if you have a carriage like Mad Max that pushes things forward. Otherwise, you lose a bit more travel as a result. If it's open like mine, you don't have anything to hit, so you can use all the space there. Tool head zero is not extruding, says someone.
Huh? Tool head zero is not extruding? Oh, it's not. Why? It's not extruding. Why? Sorry, my head's in the way. Well, it's extruding now, but it may have got caught up and just freed itself. Yeah, it's extruding in air now because it lost the last several. So I'm going to go ahead and pause this, and I'm probably done with printing this stuff, but that was an interesting experiment.
If it's in any way related to heat creep on the filament, then slowing it down may make it worse.
Yeah, and I wonder if it's related because I had mentioned I have this 22 millimeter retract, and that might be not ideal for the TPU.
That is a lot of retract.
Well, it's not retract, it's the dock. It's when the tool isn't active, it retracts 22 millimeters.
That would match stripping the filament. We saw a mist line and then we saw more. And if there's crud still on the gears that hasn't been cleared, it's going to be more likely to happen.
Let's see what it looks like. Let's pull this over and see if we can see anything. See what this looks like in here. Hidden away for a second. Don't necessarily see anything immediately. Let's just heat it up and just extrude and see if it'll extrude anything cleanly. Speed it up a bit.
Yeah, why 22 millimeters? That seems like an awful lot to prevent. I mean, was that to reduce drool?
No, the whole reason I set that is if you take a Revo nozzle and measure the distance of the, the heater to about the tip of the nozzle is right about 20 millimeters. And I heard from, I think it was Thunder Keys mentioned, he does a 22 millimeter retract on the box turtle setup for Revo. So that's what I was mimicking. But the reason was because when I was printing PLA for this stuff, it was sitting here cooking the PLA. You know how PLA gets ultra thin when it just sits there at temperature in the hot end, and it was doing an extra bit of stringing and oozing as it was going over to the wipe tower. So I figure if I can, with two solutions here, either cool down the tool head while it's docked or pull the filament out of the way. And pulling the filament out of the way was an easy change in the slicer.
Have you printed with this head before with these settings with just the TPU, out of curiosity?
I was doing these test pieces last night. They were turning out
That's
really
pretty good.
Yeah.
Okay, so you think it's the retracts that are the issue, or
It might be.
plus the retracts?
I think that's a theory. Let's extrude that. Oh, it is. There we go. Need a little more,
I learned.
a little more tension.
I'm curious, before we get to the filament giveaway shortly, if Wednesday streamers want to see more technical answers like I'm giving, or just the Steve.
Oh, I'm all for the technical answers.
It's the content that I would want.
Yeah. I think quite a number of folks in here are very interested. The de-retract speed, is that apply? So the setting I changed is here. Let me bring this over here. And under the extruder, there is a retraction when tool is disabled. Advanced settings for multi-extruder setups, and that's what that is. Now, does it use this de-retract speed as its speed to move it back? So, I don't know, but we can check that out. It might. Left to 0, the retraction speed is used. Yeah. We don't know. But. And it could be that it's retracting, and since it's TPU, it's stringing, and then might have caused a bunch of a blockage as it tried to de-retract. Does that make sense?
Yeah, if it's warm enough, it expands. So you got a plug that you're trying to push through, and if it catches, it's gonna skip some, and then it might temporarily block. I've definitely seen that.
Yeah. Let's retract that out of the way. And let's give away some filament.
I want to suggest a test. So here's what I would do. I think we tend to think differently. I tend to try to break things into individually testable pieces. Then may take more time, but then each time you get a step closer to the answer. So there are two things happening. There's the filament is sitting, and the filament is retracting and de-retracting. So can you do a print without the other head, where you force the retract and de-retract, or get it to where it's approximately that? So imagine you have a print that's quite a bit different. You have the outer shell, same thing you got, but then you have a very tiny cylinder, just enough to where it's not going to fall off over time, of the other material. And that way you're minimizing the time that the filament is sitting, and you're just basically forcing the up down. And if you still have the problem, then you know that it isn't that the filament's sitting, but instead that the up down is likely causing the clog or the problem.
You're talking still set up a 2 material print. It's just you're only printing the other material for long enough to have the first tool dock.
Yeah, the smallest possible other material. You would still have the tool change time in the way. You could optimize that as well, but I don't know if there's an easier way to do no changes of the other head and kind of ignore it, but still do a tool change like attach and unattach. I mean, maybe that's the way to do it. If you do an unattach and then an attach macro as your layer change G-code, it shouldn't affect anything. And then you can just print with one extruder and see if the attach with the, retract and de-retract is itself the problem, or if it's the combination of the up and down plus the sitting, or if it's just the sitting. You could consider those the 2 variables that we don't know the effect of, and you can at least remove one of them.
With that in mind, since we're going to dive in here a little bit, I have some doubt in my head that it's actually retracting 22 millimeters. Just because I have the advantage of being able to look at the extruder movement, and I don't know that it seems like it's moving any further than when it was set to 5 millimeters. So let's see.
I'm just going to look at the stream, but rewind it.
Oh.
I'm sure we got a bunch of people who can give us an answer even faster.
And search for, say, a T1, which should be a tool change. Get through all the random T1s in this. Okay. So
there's no motion when it docks.
Huh?
There's no extruder motion when it docks.
Well, right here, the previous one extruded -22. And then what is going on then? So then it grabs here. Let's go to one further in so we know it's gone through a cycle, because I don't know if this is the first one or whatever, but let's go a couple of these in. So the previous tool head retracted 22, it changes, and then it extrudes 22.
Oh, I see. I was looking at when it docked, but it's when it gets to the prime tower, it extrudes.
Is when it extrudes.
And I think
so it is doing it.
Yeah.
I had some doubt that it was, just based on my observation of that knob, but it does look like it is. That setting that I put in there is happening. So.
I see it on the video rewind too. I see it's about to finish the layer. You see the spin, and then it moves, and then it finishes and docks. And then after the dock, only when it's about to hit the prime tower does it spin forward and bring the filament back. So it does seem to be working from the video too. I mean, you know that because you looked at the G-code, but.
Yeah. But I don't really know what 22 millimeters looks like on that. I guess now I do when I go back and look at it, but I didn't have a feel for that before. Manually extrude or retract 22 so you can see how much rotation of the knob. Yeah, I would have to do it at that same speed to get the visual, but. Wheel of names. Let's see. Couple of things. Oh, there we go. Let me get this going, because apparently I filled out my little gift code thing wrong before, but now I have a code. Okay, giving away a roll of Polymaker filament. Get the form filled out. You have 3 seconds. 3 seconds to get your entry in. Starting now. 3. If we get a new entry, I restart the count. Did you get your entry in, Zrencha?
Did I get my entry in? No.
Yeah. Don't you
I've
want
never
some
gotten
Polymaker
entry.
filament?
I don't have space. I'll let someone else win. You're welcome.
How are we doing on likes too? Did we get to 50% likes? I hate this new, absolutely hate this new YouTube interface. I don't even know where the thing is anymore. Stream settings, here we are. We are not at 50% likes. We're not even at 100 likes. We'll get there in a second though, now that I've mentioned it. Okay, we've had 7 new responses since I was stalling for time. So we'll get to start over. 3, 2. People just forgot. They were so focused on listening to the history of Mad Max and the technical discussion that they forgot to like. 101 now. There we go. Okay, 3, 2, 1. Better get it in because I'm about to hit save. And done. Okay. There's one here just wants filament. That's okay. Tuxedo was the first one to get an entry in, and Bika, the last person. So I usually shuffle this some number of times. How many times? What should be the range that people get? Say how many times I shuffle. What's your favorite number? You don't have a favorite number?
I like 7 if I'm spinning a wheel.
Okay, 1 to 7. Number between 1 and 7. Number between 1 and 7. Gotta spike that chat. You see that at the end of the stream, I get to look at the analytics, and there's this chat graph and how busy it is. And actually, a couple of streams ago, I had a taller spike early in the stream than the giveaway spike. Okay. Because the Rancho likes 7, we're going to go for the full 7.
So I think the solution is to just give away filament, and then it'll always be spiked. Who needs actual content? Just giveaways.
No content.
Content
Magrazda.
overrated.
Congrats, Magrazda. I'm butchering that, I'm sure. Are you here? Congratulations, Magrazda. Gotta say something though. You got 2 minutes to say something. Magrazda. How else would you say that? I have no idea. They are here. Awesome. Congrats. Let's see. Let's get this. And this. Get the name in here. And one more. Okay. Email's on. Oh. Email was going to be on the way if I didn't click the wrong button. Email is now on the way. If you don't get it, send me a DM. Otherwise, that is done. Let's end this. What was the biggest thing that you highlighted as having learned after watching me go through this build? Or one thing, not necessarily the biggest thing, but what stands out? Does anything stand out?
There's what I learned.
Oh, that's a good, that's a great alternate form of that question.
I thought that's where you're going first.
Oh,
Let me answer
sorry.
that one, and then we'll maybe see if there's a different type of answer you're expecting. Thank you for taking us on this journey. And I mean that because I get to see it from a different perspective. I get to see the end user, seeing the website, understanding what's present. And I try to go for a standard of someone like Steve can succeed from just a link without interacting with the community. And in reality, everything's constantly changing. The choices are all constantly getting better. And so that's not going to happen. But if the required interaction with the community is very low to succeed, then I consider that success, that you've enabled someone to succeed and you've enabled the community to build something cool. And when you wake up in the morning, you see a new build with someone you've never interacted with, you know, at least someone has that possibility. Specifically in this case, there were a bunch of times where there was terminology that I was just used to that you weren't as familiar with. And the moment that created any kind of friction, it slowed down the build. The moment something wasn't specified that we had learned and, you know, brought to your attention sufficiently strongly, it was something that could go wrong. And I think there's a difference between a 100% project and a 90% project. And I think your stream series will help us get from a 90% project to at least a 95% project. I don't know if there's ever such a thing as a 100. It's an end goal that's very hard until you have a manual. Sure. And that's a big step. And I don't think that's something you do until you're trying for an order of magnitude increase in the number of builders. But just seeing kind of the little things slow you down and represent a place that you could get stuck, especially around the macros. So I think that's the top place to upgrade. I think the dock improvements are on the minor side, but expected and good reminders. I think making the macros, you know, plug and chug or a very clear, likely to succeed, happy path kind of thing is the next step. And it's always interesting to me because what makes a project successful at the beta level is not what makes Steve successful on a stream. Because at the beta level, the expectation is a lot of interaction over a long period of time. Whereas you're doing a stream, you need to get things working or else you don't want to go home unhappy and you don't want the listeners to do that either. And you're good at finding a way and like finding a workaround in the moment or finding a win at the end, even if there's something that's not my fault, not your fault, but it's both of our problems, right? Like if a macro doesn't work and you can't use your probe, what are you going to do, right? That's not the kind of thing you tend to solve on stream. So I think we need more documentation around the macros, a little more testing there. That's why I showed the double dragon conversion at the end, motivated by your Tridex conversion. I think every build, if it gets better, then your project is on a better trajectory, and that's where I want it to go. I think we seeded things pretty well with the beta testers and having 10 different builds, each one on a different printer type. Like there was a Micron, and there was a super wide, super tall, super deep Micron, and there was a V0, and then there was a wide V0, and there was a Trident, and then there was another, like a wide Trident here. And there was someone who used a Evoth, someone who used a Stealth Burner, and someone who used an A4T, and then there's a different A4T variant, and then there's a different V0 variant. It was just like, the fun part was trying to enable all the community creations and to try to just be the guy, you know, making this thing awesome, making the core awesome, and making this something you can build upon. But that's not enough for a lot of people to be successful. They need a recipe that they can follow, that they can get a great soup from. So I think that's my takeaway.
We have a lot of builders out there who are just at that edge. They see something cool, they want to do it, and the little details will help them be a little more successful. I did enjoy, as frustrating as some of the things were that, like you said, had nothing to do with actually the build. I did enjoy the moments in this series where we were at a stopping point, but we're able to find some way to make some progress. And especially in the last stream where I was breaking docks apparently and still ended that stream with a successful print. I mean, not a perfect print, but a successful print was very cool.
Yeah, I want to say something real quick about attitude here. I'm used to open source software development and general software development where everything's broken and it's a miracle that anything works at all, and you're happy that anything worked once, and then you try to make it work multiple times. And I think there's another spectrum of kind of an end user who only has so much money, time, attention to make a thing work and wants an outcome, right? They want a printer that can do two materials. And if anything doesn't work, it's a failure. So you go from if anything doesn't work, it's a failure, to if literally anything works, it's a success. And reality, right, is going to be in the middle. We're more advanced types if we're, you know, listening to a stream like this, and if we're building open source printers instead of buying boxes that just work, buying appliances that have no, you know, don't have the same soul as the thing that we've put our own souls into, right? That's probably why we're doing this. We feel a sense of pride when we look at our beautiful orange printers that we made work, and especially when we did the design elements for them, or we at least did mods, we made them our own.
Mm-hmm.
And increasingly, to compete with commercial, I think we've got to raise the level of the projects and the documentation. And because commercial is getting better, partially because we've shown more stuff that can be good, you know. So I think the competition for open source is stronger, and I'm hoping we can have projects like this that continue to grow. And if you do something on stream, more people are going to be aware of it, and more people are going to build it. And so I'm always excited to see what projects you pick next, because it influences the community as a big fat lever, and it can swing in a lot of ways.
What point, because I know it happened, but what point in this build series did you just want to reach through the screen and point at something or point at me?
I thought you would start that with a plural. What points?
Well, the one you want to share. Are there,
I mean, one of them is,
I know there are probably many.
It wasn't on stream, you showed me after, but when a magnet has a big fat gap, like, I understand, I internalize it. I show you data of how much that, you know, just move it a tiny bit and there goes your force. It's a miracle that it worked at all with the magnet positioning that you had.
Oh yeah.
There are multiple miracles to even get where you did on earlier streams. And then we found the miracles that we don't need to miracle anymore. Just moving the magnets makes such a difference. And it had not occurred to me that someone would not think to push the magnet all the way, because I knew intimately from the construction how sensitive that gap is for the amount of force you get. But you didn't know that, and I didn't tell you that. I didn't scream from a headline, blinking red. That's the thing to check on any dock, no matter what it is. And you should test that your flathead screw almost touches, or even might just touch and slightly rub, because you want the maximum grip there to have a successful docking every time, because you need to start with reliability. So that was, I think that was one example that pops out, where the other one, so like the flathead cap screws, the position of the magnets. Otherwise, you're pretty methodical and careful when you're building. And other times you're like the opposite. You're like, yeah, let's YOLO a multi-extruder print with macros we haven't tested. And I'm like, no, I would never do that. I would test everything in individual isolation to make sure I understand what actually works, and then I'd make sure they work in combination, because I don't expect them to work individually either.
Well,
and frequently they don't work individually.
You try the end thing first, and then if it doesn't work, then you go back and you see, go through.
YOLO makes for a better stream, though, I'll say. Like, because you want to see where it goes. You want to see if a failure is better streaming than a success.
The stream really needed to end. The series really needed to end with a two-tool print. So. And
it did. And I was so happy when we saw that. And that was, you know, a lot of afterglow for the afternoon. When
I got the success after slowing down the tool changes, that gave me I was pretty confident the rest of it was going to work. So.
I don't know if people realize the level to which you didn't just go off the hiking path. You went over a cliff into the woods in an uncharted area. Like, you push the head weight, the head positioning, the umbilicals were rigid. You did your own custom docks. You had, until we realized it, a wrong spacing. You had magnets that were useless. You had like a whole bunch of things. You have one is on USB and one is on CAN. It's like, Steve, why are you making it hard for yourself? But yes, it drives.
To be fair, I did ask you if I should shift gears from the A4Ts, and you said, no, we should try it. See how it goes.
Okay, it's my fault.
No,
it's
not.
It doesn't matter.
It's not, but yeah, it is in a good place right now.
I think,
to be honest,
you've gotten comfortable at taking risks on stream. And I think for me, not having that full experience, not having 300 plus streams, what is the number now?
311 is what it says on I think this is 312.
312 is pretty good.
That's not including like with Daniel or with Kiloprints or with Nero. Yeah.
I think I've done exactly 5 streams, 2 with you, 1 for West 3D, and then actually 3 more. I was Dueling Zeros, had some streams, and then there was Mad Max. That's it. So I'm at like 5 or 6, and you're orders of magnitude beyond that. So I think you're comfortable taking risks on stream, because you know you're going to have 5 others to kill it the next time, and then no one will remember that one that didn't work so well.
Going back to the beginning of the stream, or the channel, I've had streams where usually it's software. Usually software will get caught up. but I've had far more instances where pushing through that results in success than having to drop something and give up type thing. So it does give some level of confidence that there's some path forward, some sort of degree of progress that we can make even when things aren't going right.
And I'll just add one bit. I was really impressed. I think it was Sunday where you broke a hot end wire, hot end thermistor, and you're like, yep, we have to fix that. And you just go and fix it. And it was like an F1 crew changing a tire. 5 minutes later, you fixed it. And then we're spinning the wheel with a cat on it and someone's getting filament. That was pretty impressive.
Now, I don't want to throw LDO under the bus. I mean, that company that starts with an L and ends with an O. But that was their joint there. That wasn't one of my solder joints. I thought about that later because I'm thinking, I'm pretty good at my solder joints. Why did that break? And I realized, oh, I didn't do that one.
All right. Well, Steve, it's been fun.
Anyway, yes, thank you very much
for giving me this opportunity to share some lessons with the audience and 9 streams of success.
Yes, this was a good project, and this is going to be, I'm confident that this is going to be used more than its previous iteration. So I'm looking forward to it. I appreciate you being here. I appreciate your project here. And I'm looking forward to building the next thing that you come up with. So,
appreciate it. And this is the worst it'll ever be. It'll only go up from here. And it's already functional.
Yes. Yep. So thank you, everybody. We will be back on Sunday starting the stealth changer build, another tool changer. So that will be fun. So hope everybody has a good rest of the week. Take care and enjoy the build. Bye.